with.
All right. Good afternoon, everyone. Richard Wente and Tim O'Connell from the Tulsa Laboratory of Ingevity, and we are going to be giving a talk on troubleshooting of microsurfacing and slurry. Rich, you want to take it away there?
Yeah, let's get started. Maybe. I don't have control. When should you start troubleshooting?
I mean, you don't want to wait till the wheels fall off. You need to look for warning signs. As you see on the picture on the left, the wheels falling off. But if they would have been looking for warning signs, they would have seen that they had a loose lug nuts and a few broken ones, and they may have been able to prevent a major breakdown or problem. What we're going to cover in troubleshooting problem solving today is you need to recognize changes, how to figure out what is the source of the change, how to fix it, when was it working, what changed, where, is it a new road, a new stockpile? These are all important things to think about when you're troubleshooting. One of the most important things is as I said, how to prevent and fix problems. Two of the main ways to do that is through communication and planning. You need to have good communication between the agency, the contractor, the supplier, and then you can't really communicate with the weather, but it can sure dictate on what you're going to be doing. So you need to pay attention to it also. You need to know who to communicate, what to communicate, why, and when. For example, if the mix suddenly is getting too fast or too slow out in the field, the contractor needs to be communicating with the supplier to let them know that, hey, we need to make an adjustment to the formulation. As far as the contractor and agency, any things that are out of the ordinary or may have changed, the sooner you can communicate that with each other, the better you can plan on how to handle it. As Pat just went through mix design, some important things that are generated with the mix design: asphalt, emulsion, content of the mix. And it's important that you understand the difference between asphalt or binder and emulsion. We'll get into that a little more later, but it's important that you realize that the asphalt is the binder, the emulsion is asphalt and water, and the water is just there for consistency. So it's important you understand the difference between those two. You might have probable emulsifier content provided, good mix and cure performance.
For all the agency people on this call, the emulsifier content is determined during the mix design in relationship to the probable weather, base asphalt, things like that, and that takes the place of heat in the hot mix. So the emulsifier content is important on the mix design from a guidance for your emulsion supplier, and also how the material is going to behave in the field in terms of coating, mixing, laydown, things like that. So again, that is part of the mix design that Pat talked about and is translated to the field delivered emulsion.
And some things you need to pay attention to on the mix design, as Pat mentioned, variations in the aggregate that's been delivered to the stockpile. It may be a little coarser or finer. It may be a little more aggressive. So it's important that someone try to get out to that job with the emulsion that will be used and the stock aggregate that's been delivered ahead of time, and try to do some hand mixes or something to make sure that everything's formulated correctly. and that you're going to be able to mix those materials. Another thing, as Pat had mentioned, is the effect of the mineral filler. The mineral filler, sometimes more mineral filler will speed the mix up. Other times more mineral filler will slow it down. So it's important to know the effects of that, because you do have a range that you can add that mineral filler, and it can be very helpful on controlling the mix time and the cure time. Material performance and range, as Pat said, you'll have a design amount, and then you'll have a minimum and a maximum amount. And those are decided with the mix design. So some other questions you might ask yourself is, when did the problem start? Is this the start of the job, or has the job been working and suddenly there's a problem? Things have gone from good to bad. If it's the start of the job, are the materials the same as that were submitted for the mix design? It's the first thing you might ask or check. And if the job has been working, have there been changes in the weather, time of the day, work is being performed? There's several variables that you might look at to, go ahead, Tim.
In one instance, it was working fine during a rut fill job when the ruts were being filled, and then when they went to the surface course, suddenly they struggled with getting out of the box. Again, even the paving technique, where are you in the job in terms of the layer build, things like that, that you think same rock, same machine, just have a different box on it, but now you're struggling, right, Rich? So.
Yeah. So one thing that's very important, once you do start laying material and everything's working good, is pull some samples, retain them, get an emulsion sample, get an aggregate sample, seal them up, store them away. And why? Well, it'll let you check against known materials. You knew the emulsion was working, the aggregate was working. So with the two known materials, you can do some hand mixes, eliminate variables one at a time. Aggregate, emulsion, if those both work by hand and in the hand mix, you could have a machine issue. It could be a screen that's partially plugged where you're not getting a full flow of emulsion or full flow of water. So it can be very helpful in to reduce downtime.
And these are different than the quality control or materials acceptance samples that return to the state lab. These are some you probably want to keep in the trailer, or at least back at a site where you can get a hold of them quickly to get a new load of emulsion in. And boy, it just doesn't seem to be working like the last one you had, or get your stockpile has been replenished overnight. Now it's doing different. You can go back and say, gosh, I wonder if it's a new rock, I wonder if it's the new emulsion, or is there something else going on in the machine, right, Rich? I mean, it avoids you wander around wondering what the heck has changed.
Very handy tool to reduce downtime or solve a problem. Another important thing that I run into quite often is record keeping. It's important that you keep good records. The mix components on the emulsion, the aggregate, the mineral filler, field additive, water. And I'm not talking about, when I say a daily log, I'm not talking about what the readouts on the machine say. I'm talking about actual emulsion received, emulsion used, emulsion on hand, and maybe emulsion returned. And then check that against what your readouts on or calibrations on the machine say that you should have. If you do that daily, you can get, avoid getting way off or being off for a long period of time. Now, as far as the field additive and water, I know that I always say that the flow meters, it's important that the flow meters work and work properly. The reason for that is, well, first of all, I know that if you're talking to an operator or someone, and as a former operator years ago, I did that visually. I looked at the mix and I knew what it was supposed to look like. It didn't matter what that flow meter said. However, the importance of having those flow meters working is so that you can watch for trends. For example, when you're adjusting the water or additive in the mix, you're adjusting it to get a certain consistency in the mix. However, if all of a sudden your emulsion screen is starting to get plugged up a little bit at a time, and but you're just bumping your water up a little more to keep that same consistency, you may not notice that, hey, my water's going up. Why is that? And it's probably going up because maybe you're not getting a full flow of emulsion. It could be changes in the moisture in the aggregate, but either way, it's a handy tool and a useful thing to kind of monitor changes. You can have, as I said, variations in the aggregate as far as the moisture. You could get segregation, which could, reduce moisture in the mix or in the aggregate could cause decreased mix time. It can give you hot spots in the mix, poor workability, poor consistency. And I'll get into those a little deeper with a few videos, but as Pat mentioned, it's important to the gradation. Be conscious of contamination, whether it's a loader operator or a delivery truck that didn't get cleaned out properly before they loaded it, the aggregate to send to you. It could be all of a sudden the quarry's crushing to keep up and you're getting fresh crushed aggregate. Or there could be variations in the sand equivalency or the methylene blue. Just in case anyone doesn't understand the methylene blue test, it's a test on the fines of the aggregate, and it'll tell you how reactive those fines are going to be. The sand equivalency will tell you if they're clay-like particles, but the methylene blue will take it one step further and tell you how reactive those fines could be. And there's different things that could change the methylene blue also.
So, like Rich said, a couple common occurrences, especially something that crops up quickly, is contamination. The loader operator accidentally got towards the bottom of the pile and scooped up some of the soil from next to the pile, right? And
yeah,
man, it gets put in the truck, and all of a sudden, stuff's breaking before it even gets out of the box. Real common occurrence, and especially if you're working fast and the aggregate pile isn't real big, but it can really be a head scratcher if you don't know what's going on. So sometimes it's worth walking back to the stockpile and seeing where's the rock come from. Did somebody had a couple times where they quote neatened up the pile, right, Rich, and stacked it up and started putting dirt into it.
and
right?
if you should have what you think is a potential aggregate problem and you have a large pile of aggregate on hand, go to the other side of the pile and try that. It could be just an isolated area that got contaminated, or maybe a fresh load that just got delivered to you. So just a good few things to think about when you're troubleshooting.
For the agency people on this, moisture is actually a good thing in microsurfacing and slurry piles. It prevents segregation, right, Rich?
Mm-hmm.
Prevents really just losing fines, which is a detriment to the cure time or collection of fines somewhere in the pile where you don't want it. So again, a little bit of moisture, couple 3%, really improves the consistency of that stockpile.
It can also calm down the reactivity of it some also.
Yeah. So again, remember, we're working with not only a civil engineering system, but a chemical system, and moisture or water is part of the working fluid of that chemical system.
Excessively hot aggregate may introduce problems during mixing and laydown. A lot of times in the lab, when you're doing a mix design and you're wanting to see, in that lab it may be 70, 75 degrees and you're doing hand mixes, but you want to see what it's going to be like out in the real world when it's 100 degrees or 110 out there. So hot aggregates will speed up the reaction of the emulsion mix. Any temperature changes will affect it. A hot stockpile may also be a dry stockpile and cause breaking in the pug mill and box, which could lead to adding extra water where you could generate a false slurry. And the other thing is, we mentioned in the earlier slide, it could lead to segregation of the fines and the coarse aggregate. And if you get that, then you start kind of chasing your tail, because you're getting some concentration of fines and then a concentration of coarse, and the operator just can't keep up with those variations. So it's just important to, main thing is keep some moisture on your aggregate so it doesn't segregate, and remember that everything as far as temperature will affect your mix time.
And since this is a troubleshooting session, false slurry is what happens when the asphalt emulsion breaks prematurely on the rock, right, Rich? And then the pug mill has enough mechanical strength to break it up, and then basically it's broken asphalt on rock with the water lubricating it, right? And you're basically putting asphalt coated rock down out of the pug mill through the street, right? And that has very poor adhesion to the roadway surface and doesn't build strength very quickly. And it's black often.
Well, a lot of times when it's a false slurry, it'll have a grayish color to it, and it'll be kind of foamy looking. And like Tim said, that just means the asphalt is already broke onto the aggregate, but it's still in kind of a water phase because the mixer mixed through that and broke it up.
So again, you think, you're still paving, but you may not be real proud of what's going down the road.
But it may not matter because it won't stay there very long, most likely.
Yeah. Pat talked a little bit about this whole concept of tolerance. And of course, in aggregate acceptance, you've got material being delivered that may, be within the band, and Pat did a good job talking about. The thing about slurry or micro is not only the civil engineering aspect of the fines, but you've also got the chemical reactivity of the fines. So even moving up and down within that tolerance band can change the apparent reactivity of the mix. So even if it's coarser than maybe the mix design, but it's still within tolerance, the guys in the field may notice it's slow. It doesn't cure quickly, right? It may require less water. The converse is, if it's still in tolerance, still in spec, but now you've gotten all to the fine side of the tolerance band, you've actually have a mix with a lot more fines in it. And since the chemistry reacts on the surface of the rock, and fines have disproportionately a large amount of surface area per unit weight, it seems fast, right? So, so even though, and this is where specification and tolerance may be completely in spec, but the behavior of the mix through the paver is changing to the point where it's getting harder to pave. Again, kind of reiterating, course of the mix, you got lower surface area, it's less reactive, more mix time, and if you're doing night work or cool weather work, it could translate to a much slower break. So the more fines in the aggregate, there's more surface area on the rock in the mix. Fines often are the reactive, if not just by virtue of the total surface area, they may be the more reactive part of the rock. And again, for the machinery operator and the paver, may lead to faster break and difficulties controlling and putting out a good mix.
And if you do run into these out in the field, there are ways, as Pat mentioned, field additives. There's many different ones. It could be the primary emulsifier in the emulsion you're using, or if you're out in California, it could be something like aluminum sulfate. And these are fine, but they're not usually meant to be used in excess. So if you do run into these situations, once again, that's where communication comes into play, and you need to be communicating with your emulsion supplier. If nothing else, give them a heads up, because sometimes they may have enough emulsion to supply you for several days, to where if you wait until it's a real problem and you're shut down, they may not have space to make a new run of emulsion to reformulate to help you control that system.
And of course, when the mix appears more reactive, people tend to kick a little more water in, right, Rich? So yeah, that's often not a good thing from a cure point or even durability standpoint.
Something very important to always remember: the more liquids you put in, the more liquids that have to come out. So that's where, once again, using field additives to, they work as like wetter than water, to where you can maybe use 1 gallon of a field additive and reduce your water by 10 gallons. And the field additive will give you the mix time. However, the fact that you're putting in less total liquids may help your cure at the same time.
Okay, the aggregate contribution to performance and issues in the field. I guess gradation, we talked a little bit about working within the gradation bands, the mineralogy, even different shelves in a quarry, rich contamination, dirt, clay, fines.
These can be caused by changing crusher or processing speed. Recently crushed aggregate, as I mentioned earlier, can be more reactive. Or it's possible that they get into a slightly different ledge and the mineralogy changes slightly. So these are all things to be aware of. And when, one thing you can want to pay attention to is the color of the aggregate. I've seen situations where I get 3 or 4 buckets of aggregate out of the same quarry, and one is red and the rest are kind of off-white. It's just a vein running through there, and it's something important to pay attention to. If nothing else, it may not hurt anything. However, it's something to look for. As I said earlier, look for changes, and that may be something to pay attention to be aware of, to troubleshoot if it becomes a problem. Mineral percent and the effects. Total fluids, as I mentioned earlier, total fluids can have a significant effect on workability. If you get too much in there, it tends to, you'll see where the liquids all want to run away from the aggregate. You drop out a pile of mix for handwork, and you've got a pile of black rock in the middle, and the liquid's running everywhere. And it makes it harder to control workability as far as along a curb line or something, because you can't control the flow. It can have a significant effect on cure time. And these are all, when I say total liquids, water, emulsion, additive, those are all liquids that are adding water or moisture into the mixture. It can have segregation problems, to where, as I said, you drop out mix, instead of staying a nice homogeneous mix, the aggregate falls out of suspension. Those things can lead to raveling, because if your water and fines flush away from the larger aggregate, then your larger aggregate isn't well embedded, and it will possibly kick off the road. It can also lead to bleeding, because if you get too much water in there, you can possibly float the asphalt, which could lead to a bleeding, slick liquid surface, flush surface.
You gotta remember, rock weighs about a specific gravity of 2.3, 2.7. So if you get a 2 fluid, asphalt is approximately the same weight of water, and it sorts itself out, right? Mm-hmm. So you'll get an asphalt-rich surface, which, is sticky, pulls up, things like that. A lot of those things that have the short-term issue associated with them.
So these all go back to having good control over the system. And like I said, there are some things you can do out in the field, but they are limited how far you can go with those. And there are times that it's necessary to adjust the formulation of the emulsion to get the system back under control.
And for all the pavement engineers on the call today, since we were fortunate to have a lot more people, in asphalt emulsion systems, heat is not always your friend. I think in hot mix, boy, if you have work differences in workability and coating, just warm it up a little bit. That is not true in slurry and micro. In fact, it may have the opposite effect, right, Rich?
Yeah.
So, and it's really this concept of total fluids, which means the asphalt emulsion, the add water, the water that was present on the aggregate, the additive. That's what gives you your fluidity and your ability to pave across the width of the lane, right? So it's not heat. It's this concept of total fluid that provides the choke and flow and lubricity, and ultimately, assures the success of your job and makes it you able to pave with it. So,
okay, now in this is a short video I wanted to show you. This is just an example of an aggregate that's completely dry, and you see I'm already putting water in there, but you can see the coarse material and how segregated it is. And this, we add some water into it. I wouldn't pay attention to the amount I add in, but just the fact that I add in water and I mixed it in just to get some moisture in it so that the aggregate wasn't segregating, and it had a little moisture in it to kind of calm it down some also. There are some other things that can happen if you have to add, if you're post adding too much water because your aggregate is dry, and we'll get into those in a few slides later. But we'll go on to the next one. I just want to
and we're trying to simulate the machine like Pat showed us. You know, the first additive that goes into the aggregate coming out of the machine is water, right, Rich?
Right.
So this is, we are in a sense replicating the mix. So
now here's an example of a mix. There was 4% moisture in the aggregate. I added 4% more moisture into the aggregate for a total of 8% moisture. I added in my emulsion, and then I started to mix. It did have the proper amount of mineral filler in there and everything also. Hopefully you can see this, but my mix is a little stiff, but it is mixing. And I could have compensated by a little bit more water and thinned it out if I wanted to, but this is just to give you an idea of how having water in the aggregate ahead of time can help. Now,
we'll do it again. You know, and a couple of telltales there. It's not grabbing onto your mixer, right? And it's not turning black, right? It's staying a nice chocolatey brown, which means the emulsion's not breaking yet, right, Rich?
Right.
So it is, you know, it's sort of a texture, and what does it look like when you're troubleshooting? And this can be done in the field. This doesn't have to be done in the lab. So.
Okay, now the next one, what I've done here is this is a completely dry aggregate. I just added 8% moisture into it, mixed it up, then added my emulsion. Same procedure as far as, other than I added more water to get the same total liquids into the mix, and then see what happens. So you can see that water being in the aggregate a little bit ahead of time will calm it down. This mix locked up within a few seconds and barely got the aggregate coated.
And that's what most asphalt emulsions are used in slurry and microsurfacing are fairly aggressive. They're looking to deposit themselves on the surface. So if you can get some water on the surface, that helps get you to the point where you have the requisite time to get it out of the pug mill, right, Rich?
Yeah.
And down to the, got a picture here of the machine.
Okay, now the next thing I want to say or kind of show you, and this can magnify what we just demonstrated in the videos with the hand mixes. You see where the water goes into the mixer? It drops right on top of the aggregate as it falls into the mixer, and then a very short ways down the mixer, you see where the emulsion goes in. Can you get your pointer out?
Yep.
This is a little schematic of showing kind of, you can see the yellowish tan color coming down in, that's the aggregate. The water's coming into it right there. If you look at the lines drawn and arrows pointing to where the water's coming in, you see how short of a distance that is from where the aggregate and the water get introduced and before the emulsion hits them. So it's a very short mixing time. So if you have to add a lot of water at the mixer because your aggregate is extremely dry, then there's a good chance it's not getting mixed in thoroughly before the emulsion hits it. Once the emulsion hits that, your timer starts. It's not like basketball where you can call timeout. Your timer starts until there's a good chance that you get out shovels and shovel that mix up because it broke too fast. Because what happens is that dry aggregate, when the emulsion hits it, it kind of flash breaks. Now the wetter aggregate may mix a little bit, and it may break up some of the mix that's kind of broke too fast because the aggregate was too dry. It may break that up and jeopardize the long-term durability of the material that you're laying onto the road. It can also affect the amount of mix time that you have or time you have to get that material placed. So it's important that you don't try to add excessive amounts of water right at the mixer. If you can have, even if you have to put sprinklers on your rock pile or dig a whole trench in the bottom of it and dump some water in there and stir it around, it's a good idea to have at least, around 3% moisture in that aggregate, not only for segregation, but as you can see in the videos and what we're showing you here, it can have a significant effect on the mix time that you have to get that material placed.
And when you think about it, aggregate, when it's wet, you are solubilizing some of the mineralogy there, even though you think, well, rock doesn't dissolve, but certain parts of it want to in the surface, and that gets those in suspensions where you hit it with dry rock, like you say, it can flash break, it wouldn't dehydrate, it'll, and it poor coating and hard to handle, right?
Mm-hmm.
So a little water is useful. Just to, kind of to amplify on that, asphalt emulsion, of course, is a finely dispersed asphalt suspension and each one of those little asphalt particles have got literally millions of molecules surrounding them that make them suspend in water. They actually make it water philic that on their tails and they provide a way of holding that material in water. So once you get it near a rock, and this is a close-up, slightly diluted of the material particles, you can see the asphalt particles, see the aggregate surface. Once the pH changes, once you get the mineral filler in, once the break mechanisms start, it actually becomes attracted to the aggregate. You can kind of see the aggregate, the asphalt particles can be depositing. So this is about a number 30 aggregate. So this is a pretty small piece of aggregate, but you can see proportionally how small those asphalt particles are. And this is just a snapshot right as breaks starting to occur. This should be happening arguably, Rich, after it's gone through the pug mill, after it's gone through the box and then the street, right? Yeah. If this has occurred in your pug mill too much, you're going to have black coated rock leaving the pug mill and potentially be struggling with stickiness and drag marks and things like that, right? So again, you got stable emulsion here, the additive, the aggregate begins to react, the asphalt particles become more attracted to the paved aggregates instead of the water, and they begin to deposit on there. So that's the mechanism. It's not heat, it is reaction with the surface of that aggregate that causes the material the asphalt to deposit on it. And when we talk about formulation, we're just trying to control the speed. How long does it take in those few seconds that it enters the pug mill and goes into the box before those asphalt particles as a group begin attaching, right? You can sort of see these are beginning to coalesce, stick together. So again, that's what the operator and the mix design and the asphalt emulsion formulator all work together to achieve. Right, Rich? Mm-hmm. So, okay. Okay, so these are the, when Pat's doing the work, or we're doing work here in the Tulsa lab, this is what we're thinking about. How warm is the weather going to be? How warm is the air going to be? What is the formulation